the y behind our special triangles. So y, if this is 1, this is 1/2, and this is root 3 over 2, and if this is 1, then this is root 2 over 2, and this is root 2 over 2. Why? I told you everything in math makes sense. You don't have to memorize anything. Well, this doesn't make a lot of sense right now, does it? Let's start with the 30, 60, 90 case. It all starts with an equilateral triangle. An equilateral triangle 60, 60, 60 with side lengths 1. Well, that equilateral triangle gets cut in half so that this is a right angle and that this is 30 degrees. The angle's bisected, so that means we have 2 equal lengths here. Since this whole side was 1, this side must be 1/2. So that's the reason behind your 1/2 there. Now how do we get the missing side? Well, we know a squared plus b squared equals c squared. And so that's pretty much how I get the rest. Let's call this a. Then we have a squared plus b, which is 1/2 squared, equals c squared, which is 1 squared. A squared plus 1/2 squared, which is 1/4, equals 1 squared, which is 1. A squared equals 3/4. A equals plus or minus, but since we have side lengths, I'm just doing plus root 3 over 4, which is root 3 over root 4, because we can split it up like that, and we have root 3 over 2. That's the y behind our 30, 60, 90 triangle. Our 45, 45, 90 is even easier. So in this case, we know this is 1, this is 45, and this is 45. Well, since these angles are equal, then their side lengths must also be equal. And so in this case, we have a squared plus b squared equals c squared just becomes x squared plus x squared equals 1 squared. 2x squared equals 1. Divide both sides by 2. X squared equals 1/2. X equals root 1/2. Again, I don't need my plus or minus because I'm dealing with side lengths, which is equal to root 1 over root 2. Root 1 is simply 1 over root 2. Of course, we've got to rationalize that denominator. And that's where we come up with our root 2 over 2. Thus, our 45, 45, 90 triangle.